Now, of course, over the years, we've produced and used a lot of these plastics, right? So in fact, the estimation is that over 9 billion tons of plastic has been made since the 50s. And so that's a lot of plastics. And what we find is they don't get reused that easily. The reason they're so good is because they don't really break down that easily through natural processes, unlike things like rubber and other natural polymers. So as a result, we're trying to figure out better ways to use plastics in the future. And so one of the approaches that we use is called 4Rs, where first is you try to reduce just the amount of plastics you're using in making anything at all, right? And then for the plastics that you have, you try to reuse them as often as you can. This is why there is the movement to use your own grocery bags. And that's the reason why in California, grocery bags are no longer handed out, but you have to actually purchase them. The idea being that you want to encourage people to reuse the bags and recycle them. So if you no longer can reuse them, let's say the bags are completely torn, you can still recycle them, so you can put them in the appropriate containers so that they could be reused to make new plastics, perhaps, right? Lastly, recover the materials or the energy content. So if they cannot be recycled to make new plastic, perhaps there is energy that is stored in the chemical bonds, as you recall, of the materials that we use to make the plastic. So maybe we can use some chemical reaction to recover that energy content and then use them to make something else. Use the heat perhaps to make something else. Okay. So in this last video about the chapter on plastics, I just want to talk about the idea of recycling plastics. We start by talking about this term municipal solid waste, or MSW. This just means all the waste that you throw into your trash. This includes, food, grass, appliances, or any other thing, plastic bags and so on. Now, of all of the waste that is discarded, which is shown right here, plastics is not a huge portion of it. It's about 12 to 13%. Everything else is shown right here as well. Even though it's not a huge component of waste, right? The problem is that it's really hard to recycle plastic. So only 9% of that 12% is actually being recycled. And the reason for this is because some of these plastics are just impossible to recycle. So this shows you the 6 different plus the 7th one here, but these are the most common plastics we discussed previously. And some of these are easy to recycle, like these first 2 here, the PET and HDPE, the high density. But then some of the other ones are harder. So like these bluer ones, you can recycle them, but it will take a little bit more work to do them. The brown one and this gray one right here are almost impossible to recycle. And then the PS, the polystyrene, is difficult to recycle. So again, difficult means you need to expend a lot of effort to do it, which means costs, and there's no economic benefit to doing it. Then a lot of times people wouldn't do it. So it just gets dumped and it stays there because it doesn't degrade that quickly, unlike organic materials. So you might remember our discussion early on about the circular economy and the cradle-to-cradle concept, where we plan ahead when we design a material so that we include in that planning how we're going to dispose of that item or repurpose it at the end of its current useful life. Up to now, people haven't really done that, at least not in a major way. So if we want to keep using plastics in the future, that's definitely a concept that you want to incorporate into the designing of new plastic materials. So right now, recycling goes through these steps where as consumers, we put our materials in the recycling bins and then somebody takes it to the waste station, but then it has to be sorted first, right? Because there's all those different types of plastic and some of them are easier to recycle than others. They go through their specific reprocessing, which pulls out the useful material and then reuse that to make new plastic materials. So for example, those plastic bags could be recycled, reprocessed to make new plastic materials, right? So that's why a lot of times you'll see if you buy some items that's made out of plastic, it will say it's made out of recycled materials, because the material has gone through this process right here. And so then it goes back to us, and then the cycle continues. To make that recycling process a lot more effective, where we use less and less material, we really have to increase the efficiency a lot of times on some of these steps. Particularly, as we said earlier, some of these plastics are just hard to recycle, so perhaps it's useful to come up with, as a chemist anyway, come up with an alternative molecule that we could recycle more easily that still has the same properties as the item that's being replaced.